a math shirt on again. I wear this often. Without math, there would be no NASA. So anyway, we're going, man. I got no time to waste. Okay. Move myself up in the corner here. I think that's a good spot for me. Okay. All right. So gonna yell at you. I just told 6th hour because I yelled at 5th hour. I went to YouTube to see how many people actually looked at the last 5 minutes of that, just to see those examples and figure out what's going on because they care and so on and so forth. I don't think it's going to work when I hit it. It takes forever to load up, but I noticed that there was only 14 views and I have 80 some students. So that actually tells me a lot. It does make me upset about what I see going on. That's why I get a little frustrated with what can I do to do better when I see 14. And actually, I think of these 14, one of them's me because I count it as a hit. It does get upsetting. So that's why I don't play the games. Huh? Hey, that's me. Uh, I don't know who's talking. Hold on. Hold on. Who's talking right now? Oh, okay. I've never seen that before, so I don't know. So 14 views. I think it should be more. I really do think that should be a thing. So that's all I'm going to say. Okay, so let's move on. So we're going to go to 2.5, and I'm going to do the parts that really pertain to how we ended the last part of the movie, and we're going to fall short in this little 25-minute scenario. So I'm going to hide. Oh, I think did I end that video? No, I didn't. I think I'm still going. Okay, do not write this down. This gives the book props, though, if you read, and sometimes the reading is a little bit tough. What's the fundamental theorem of algebra? Here, it's real easy. The degree of the polynomial, that's how many zeros you're going to find. Simple. That's it. Let's move on. What's the linear factorization theorem? Hey, don't zeros turn into factors? So the amount of factors you will have is equal to the degree of the polynomial. Again, these two formulas say the same thing. So when you find zeros of a polynomial, expect the amount of zeros equal to the amount of the degree of the polynomial. But just do remember that some zeros could have multiplicities. So those multiplicities are part of that scenario. So if you have something with multiplicity 2, that really counts as 2 of those zeros. All right. The friend's back. All right. And then, as stated last section, turn the camera off now. Solutions, roots, zeros, all synonyms that turn in for the graph into x-intercepts, all interrelated, intertwined with each other. And then I could turn those solutions, root zeros, into factors for the polynomial. So this is all stuff that we should have going into this section. Then one more thing, how is 2.5 going to be different than 2.4? One minor difference, the almighty I number. Okay, we're now going to have zeros that are actually imaginary. So we have to remember what the imaginary unit is, which is I equals the square root of -1. I squared, we're going to have to remember, equals a free -1. All right, remember that I squared equals a free -1 because that is going to be part of our math today. Oh, and then one more thing. We're doing this in math 2 right now. Graphically, what occurs with which type of zeros? This first one, this is when we get 2 real zeros. And I'm keeping this with quadratics. Like this is a picture of 3 parabolas. It was just a thought to bring up, things when you practice this. And I think you actually did polynomials in math 3. This is one real. You already know this though. This is a real with multiplicity 2. So remembering that a graph, at least, it could be multiplicity 4, 6, 8, 10. Any even multiplicity would be this picture. Oh no. Now what happened with the parabola that didn't cross? Whoops. That's when you got 2 imaginary zeros. And then do understand that when you get imaginary zeros, that means the graph is not actually crossing at that particular position. So just recall that as we move forward. Now, I am going to reference this. Oh, I'm sorry. The book is really tough to read. It's really not that bad there. I don't want to rip on it here. Here's the complex conjugate theorem. And all it says is this: if a plus bi is a 0, it says more than this, but we got to get to the brass tacks of stuff in this, this environment that we live in here. Then a minus bi must be a 0. They must come in conjugate pairs. Now there's other stuff in here, like it's only if the polynomial has real coefficients. That's the only polynomials we deal with. So that's, that's for sure part of it. And it really is because of the quadratic formula and that plus minus part when you're solving quadratics. Don't write all this down. I see people furiously writing. This is just giving the book props that, yeah, they describe it in the book. I just want to shorthand it. And actually, I've done it every year, even without COVID being part of the situation. Really get to the brass tacks of it so we can move on and actually use it and do our math well. Don't write any of this down. I'm not going to be able to get to this today. First thing that they start off with the homework, though, is here are the zeros, find a polynomial. This is just wrong. I wouldn't do that anyway on this one. I would FOIL these first, and then I'd get it actually easier answer. Get that answer, and then FOIL it with this. That's what the first 3 examples are. And I don't even think I'm going to do 3 of these tomorrow. We are going to talk about multiplicities, though, and how that one works. Really want to stick on the synthetic division part and really piggyback off of how we ended our last notes. So in exercises 27 through 32, fine, I just pulled this out of the book. Who cares? Find all of the zeros. That's what we did yesterday. And then write a linear factorization. This ain't no thing. If I find 0 of being 3, then a factor would be x minus 3. And then that's writing a factorization. So it's really the same question, just writing it in a different form. It's writing this polynomial in factored form instead of just listing the zeros. Okay, so giving you a chance to write the question. Oh, you really get a chance because I'm going to take forever on doing this. So you know what happened yesterday. You had to type in this when you're not given the picture. Okay, so we're going to go ahead and do that. We're going to take our time. So this will give students a chance to catch up. X carets 3 out minus 10x squared plus 44x minus 69. All right, so we're going to use the graphing calculator as an aid to find, at least do we see one of the zeros. That's all we really need. We got to depress this down to an x squared so then maybe we can factor. Oh, now I'm in the way. Not really. Okay, because look, I guess I'll expand this out. All right. And then here's the thing. Oh, talk about those quizzes, which I did. I'm working through them, almost done. I wanted to grade them by hand. It actually was kind of fun, even though it was a lot more work to actually watch written work if you did it. By the way, some people left all the written blank. Hey, caramba. Okay, but those questions where what's the graph? I think it was in the multiple choice. There was like 5 of them. I was hoping that was a chance for you to get 5 questions that were easy, correct. Just knowing that an x to the third does this, um, that's what we should know going into this. So just knowing that that's what I'm seeing right here, that part that I circled, do you kind of want to, that's all I'm seeing right now. If I wanted to see more of this graph, I would have to expand up on the y-axis and right on the x-axis. But I'm good. Look at, I could see that looks like 3 is a 0. And that was an accident that I mentioned 3 over here to the right. 3 is a 0 and x minus 3 is a factor. So I see that 3 is an x-intercept, which makes it a 0, and I'm going to prove it. So yeah, you need your graphing calculator. It makes your life a lot easier. You should see what the students back in the olden days had to do, like way back in 2012. Back in the day when, they wrote on rock tablets and wait, really, that's not that long ago. It really seems centuries ago, though, the way the world is now. I blame the phones. I think this has really changed the world in a very negative way. Anyway, that's me just going on a diatribe here. 3 times 23 is 69. Boom! Proof that the 3 that I saw as an x-intercept actually is a 0, and there's the correlation. Remember, what's a factor when the remainder is 0? And this is the remainder position right here. Okay, so now what do I have? I have a depressed polynomial. Oops, that's a mistake. All right, and then I got to find the remaining zeros. So what else makes this inequality or this equation 0? Sorry, slipping up with the words here. Well, there is nothing that multiplies the 23 and adds to -7. So I think in some of my classes, I actually played the song, which I do have on the calendar. I have it right here, the quadratic formula song. So it's the one that I've been singing, and then I played it in a couple classes, and some people look like they wanted to throw up, and some people look like they enjoyed it. I don't know. You can't make everyone happy. Just remember that throughout life, no matter what you do. You're never going to make everyone happy. All right. The opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And I'm not waiting on this. If you don't know the quadratic formula, that's part of the things of what's, it's not just COVID, it's not just you this year, it's every year. I have CAT students coming in with not just the math that they need to succeed as of right now. So they need to do more. If they decide to do more, they'll do better. If they decide not to, they won't. That's reality. Okay, so 49, I don't feel like calculating, minus 4 times 23, meaning I'm pushing it on my calculator here. Oh, that's nice. The reason that's nice is I know 43 is a prime number. But what you have to do is this. Here are the zeros. The zeros are, well, we saw 3. I don't know why I put a parenthesis. 3. And then I see this 7 plus or minus 43 is a prime number, so nothing simplifies. There we go. That's why I talked about this up here. I'm not going to scroll up there. The square root of a negative is an I number. It must be written in terms of an I number. So there's finding all the zeros. Done. But now how do I write a linear factorization? Little weird. F of x equals, first one's easy, x minus 3. Ain't no thing. Chicken wings. Next one's a little bit strange. Yes, I have to do x minus 7 plus, I'm going to run off the page, root 43i over 2. This always makes me sad. Parenthesis, off the page, x minus parenthesis 7 minus root 43. You need that second parenthesis. Probably should have brackets at this point. An English person would probably be mad at me. Oh, this is going to be on YouTube. I don't want to get a bad reputation as this goes viral, So we're going to go ahead and put brackets on there. So then people on Twitter start getting judgmental. Can you believe he put parenthesis, then parenthesis? He should be fired. All right. Twitter. That's what it's good for. Just ripping on other people. All right. Anyway, there, we made that correction. Okay. So don't think writing a linear factorization is a big deal. Okay. All right. All right. Okay. For those that didn't watch the YouTube video, and then whoever was talking, I think I know who it was. I bet you're right a little bit about the algorithm. Let's be honest. I know a lot of people didn't watch the video. Okay. It happens. All right. I got a lot of people not doing what they're supposed to be doing, and it drives a teacher nuts. Okay. So here we go. Got to do this again. Yeah. Okay. So I'll write it real small here. This will give you time to catch up. 3x caret. It's part of why I think the world is going down the tubes, because we listen to these people that all they have nothing better to do than to complain about the world on the internet. Oh, I know there's problems. There's always been problems though. Heck, I lived through the 80s, 70s, 90s. You don't think there were problems back then? There were. Lived through a lot of stuff. Okay. 3x to the fourth plus 8x cubed plus 6x squared plus 3x minus 2. Just want to double check that I did that right. And if you didn't get a chance to write that down, there it is in big format. Okay, then do look at this. Ooh, I had that y2 equals 0, which will allow me to use a feature if I need it. Okay, so we're waiting for a sec. 1. Here we go, graph. Let's see what we get here. Wow, this is lightning fast. Oh, there we go. Ooh, I could see that one as -2. Ooh, I don't know about that one. Let me just do that -2 and let's see if that's actually true. So again, I'm emulating what the student has to do. That's you. Okay, I see that it looked like -2 hit perfectly. I'm going to prove it. I'm going to prove it's a 0, prove that it's a factor, because I'll get 0 as a remainder going through the synthetic division thing. -2 times -2 is 2. 2 plus -2 is 0. Boom, shakalaka. What I saw on the computer or calculator, it says on the computer, but not necessarily wrong, proved that this is an x-intercept /0, which I'll be able to turn into a factor. And I'll write that in my final answer at the end after I get done with all my work. Now, for those that didn't watch YouTube, I guess this is taking care of what you did yesterday or did not do. But this is a problem. And this happens in yesterday's as well. I don't know what that is. And I can't really just make a guess. So I really have to go ahead and calculate, not a 0, because I put y2 equals 0, a second graph. I can do the intersection. Then you can see this red graph right here. As long as I have the second graph put in there, the intersect feature will work. And then I just have to go close. Ooh, you're not close. It doesn't matter. You're close enough. First curve, second curve, guess. You have to enter 3 times. 0.3 repeating. Now, I am infinitely sad for those that don't understand what 0.3 repeating is. It is not good if we don't. 0.3 repeating is 1/3. And notice where I'm putting it. I'm putting it here because I'm going to synthetically divide this depressed x cubed. It was an x to the fourth, and now it's an x cubed. I'm going to knock that x cubed down to an x squared. The biggest mistake people do is take this 1/3 and go back up to here and synthetically divide this x to the fourth, and then they have 2 separate x cubes. Then they can never find the last 2 zeros. So this is an imperative step that you follow, and if you don't, then you're going to be lost. Bring down to 3. Oh, this is easy. 1/3 of 3 is 1. Oh, look at this. 1/3 of 3 is 1. Oh, look at this. 1/3 of 3 is 1. Oh, look at this. Boom shakalaka. So it is proof that 1/3 is the second 0. How many do we have? 4. That's the fundamental theorem of algebra that I flashed at your face in the beginning of this without letting you write it down because it's not really a big deal, and I think it's something we should know. Now, there is a wrinkle about this 1/3 being a 0 when you talk about the linear factorization, but we're not there yet. Let's get all the zeros. This is now depressed down to a 3x squared. One more time. We went from an x to the fourth to an x to the third. Then we depressed it again. Now it's an x squared. Okay, so that's imperative that you go in this step in this fashion in order to get down to a workable x squared that can be either factored to find the remaining zeros or, well, first things first, I'm going to divide both sides by 3. Perfectly legal. And I'm going to distribute that division, and we should know that 0 divided by 3 is still 0. So that makes this easier. Nothing multiplies to 1 and then adds to 1. So here it comes again. To find the remaining 2 zeros, it's the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And then you get -1 plus or minus the square. You got lucky again. 1 minus 4 is -3. This is not a perfect, there's no perfect square in there. 3 is prime. The only thing you have to do is write the zeros. Okay, now watch what I do here. Zeros are fine. You got -2. You got 1/3 from the calculator. Then after you double the pressed, you got -1 plus or minus square root of 3i. Write this in I format or I'm going to get you. If you write this on a written test and you don't write it in I format, at least a half a point off. You're gone. Okay, so those are the zeros. Here is the prime factorization. Actually, I don't want to highlight that. Not sure why I did that. Because I want to highlight something very specific in the prime factorization or the linear factorization. I don't know what I'm doing. It actually could be called factored form as linear factors. F of x equals, well, the first one's easy. X plus 2. Don't be missing that. But now we got a wrinkle here. This 1/3. Someone might be inclined to say that it's x minus 1/3. And you wouldn't technically be wrong. That is correct. But it's not correct in the context of this question. Look at the leading coefficient on that x to the 4th. It's a 3. So how does that happen? Well, 1/3 actually is a 0 for 3x minus 1. That is true. Add 1, divide by 3. And you're going to need to do that because that is the only way, if you foiled out your answer, that you would get this question, 3x to the 4th with a proper leading coefficient. So I will say this, if someone wrote this as a factored form of that, you would get a half point off because it doesn't match the question. And I really hope you understand that, as we move forward. It's just double checking at the end, making sure your answer makes sense to the question that you're dealing with. And then I'm going to tell you what, we're going to be lazy on the last one. We're going to write 2 zeros at once because I always thought this was a strange thing to do. Oh, let's do the brackets so the people on Twitter don't go firing off. Where's teacher ever? Brackets and parentheses. Okay, -1 plus or minus √3 I over 2. Put them both in this, and then that takes care of 2 factors. Just put the plus minus in there because it's a really silly thing to write a factor from this. Oh no, I completely lost track of time. So I guess you could either watch or watch the end of this video. I did this one last, when I'm done with it. And I didn't do those other ones in the other classes. So I'm going to keep going. Okay. And then I'll finish the video. Hey, and you should watch because you showed up after the bell anyway, but some people already left. Hey, I get a nice little email who stayed and who goes and what time you come in and what time you go. So that's always fun. Check that later. Hey, it says find all the zeros and write a linear factorization. I don't believe I did that on this question. I might have. With the given 0. 3i is a 0? Okay. If that's true, hey, by the way, look at how much space I'm writing. Then I should be able to synthetically divide by it and get 0 as a remainder. So that's what I'm going to do. Spattermack, the last class, it's almost about the exact same spot. The bell rang and I was like just starting this. So bring down the 1, and then 1 times 3i is 3i. There they go. I'll see you on the timestamp. Now, what's 4 plus 3i? It's not 7i. I can't help those that actually do that. You've automatically destroyed this question. It's actually just 4 plus 3i. I don't know why I changed colors. Should I go back to that blue? Everyone just calm down. Because then the next thing is you take this and multiply. Ain't no thing. You get 12i distributing. And then you get 3i times 3i, which is 9i squared. And then that goes back to what I put up at the top. What is I squared? It's -1. What's -1 times 9? -9. What's -9 plus 11? 2. But the 12i is stuck with it. It's 12i plus 2. So this becomes -9 plus 11. These get to mesh together with each other as like terms, I guess is the best way to say it. Then we do this. 3i times 12i is 36i squared. Oh, nice. Oh, no. Plus 3i times 2, which is 6i. Same thing. This is negative 36. Negative 36 plus 36 is gone. And then you're left with just a 6i. Oh, now that's easy. 3i times 6i is 18i squared. Guess what 18i squared is? Negative 18. Boom, shakalaka. And then, remember the complex conjugate theorem? If 3i is a 0, I don't know why I erased that, then negative 3i must be a 0. Now watch how easy this is. Absolutely. Negative 3i. Remember, this is an x cubed now. And we're going to stop right here. 1. Oh, please. Negative 3i, 4. Woo! Negative 12i, 2. Boom shakalaka. Proof that 3i and negative 3i are zeros for this polynomial. All right. How do you find the remaining zeros? I already did this in the previous 2 questions. The opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And then what's the linear factorization? Just x minus the zeros. And then x minus whatever zeros you get from the quadratic formula. So I don't think I have to show another quadratic formula. I think I'm done. We should know how to do the quadratic formula anyway. Should be all good. All right. Thanks for sticking on. Do appreciate it. Have a good rest.